The personal computer is often presented as a product of pristine, sterile laboratories. We envision engineers in white coats handling silicon wafers with vacuum-sealed precision. But a much more chaotic history is written in dimly lit bedrooms and grease-stained garages. This is the realm of hardware gore, where the instruction manual is treated as a personal insult to one's intuition. In this world, the IT support technician acts as a digital coroner. Instead of troubleshooting mechanical failure, they are investigating specific acts of hardware homicide. A modern PC is a precision electrical instrument, yet we frequently treat these components like a set of indestructible Lego bricks that can be bullied into submission. As hardware becomes more expensive and user-friendly, the respect for the underlying physics seems to plummet. The result is a daily graveyard of highly preventable technological deaths. The most aggressive errors stem from the Power Tool Fallacy. This occurs when a user decides a lack of physical compatibility is a design flaw they can correct with a drill. In one legendary case, a user with a $600 GTX 980 Ti found the cooling bracket didn't align. They didn't reach for a different bracket. They reached for a power drill and began drilling through the PCB to force the mount. This illustrates a total misunderstanding of board architecture. A modern GPU is not a solid slab of plastic. It is a multi-layer sandwich, often 12 layers deep, containing thousands of microscopic copper traces. By drilling into the board, the user severed hundreds of signal lines and power planes. In seconds, a high-end component was transformed into a very expensive piece of electronic Swiss cheese. This same logic leads users to hammer RAM into slots, ignoring the physical keying notches designed to prevent a short circuit. The force required is enough to crack the fiberglass substrate and migrate shorts across the entire motherboard. Structural modification is a guaranteed death sentence for silicon. Physical force is not a valid workaround for a mismatched component. When builders aren't smashing their hardware, they are suffocating it. The Verge's infamous 2018 build video demonstrated that even a $2,000 budget is no defense against basic mechanical illiteracy, especially when zip ties are mistaken for tweezers. The build featured a catastrophic thermal management strategy, applying a massive glob of paste over a pre-applied layer. Mixing different materials in these quantities traps air pockets, turning a conductor into a thermal insulator. The budget overclocking community has explored even weirder limits, replacing professional materials with mayonnaise, a tube of regular toothpaste, or even sweet, sticky honey. The logic is very simple. Wet things transfer heat well. While the water content provides a brief window of efficiency, the heat of the processor soon leaves behind a crusty, desiccated residue. A PC cooled by egg yolks and vinegar eventually becomes a biohazard, signaling the departure of both the warranty and the user's social standing. A more specialized chemical disaster occurs when users apply liquid metal, gallium-based thermal paste, to an aluminum heatsink. Through a process called grain boundary diffusion, the gallium physically infiltrates the crystal structure of the metal. It wedges itself between the aluminum grains, breaking the internal bonds. Within hours, the rigid aluminum bond breaks down. The solid heatsink begins to weep and will eventually crumble into a brittle alloy that can be crushed by hand. Ignoring the laws of material chemistry ensures that a cooling solution will actively dissolve the very hardware it was meant to protect. Beyond chemical errors, technicians encounter outright biological hazards, documented in the H2iK Technology Solutions Incident Archive. Case 0220V reveals the death of a flagship RTX 4090. High-viscosity strawberry vape juice leaked from a shelf directly into the top exhaust of the chassis, dripping slowly onto the components below. The liquid was conductive enough to bridge the pins across the socket and DIMM slots. One sticky, artificial strawberry-scented residue was all it took to trigger a total system loss. Other cases involve the forbidden cheddar, years of skin cells and pet dander compressed into a matting. This buildup easily friction locks fan bearings. Technicians have even recovered servers that became lamel ant colonies, finding comfortable warmth directly inside the protected chassis. One laptop drowned in personal sexual lubricant required a specialized discomfort surcharge for the cleanup. Some things cannot be unseen or unfelt. The most advanced computational hardware on Earth remains utterly defenseless against the repulsive personal habits of its owners. The wreckage in the tech support morgue points to a specific psychological pattern, the belief that a bit of confidence is a substitute for engineering context. We assume that because we can see the physical components, we understand how they work. We assume that if a cable has a certain shape, it must have a certain function, and that if mayonnaise is creamy, it must be thermal. This pile of mangled pins and charred boards is the ultimate proof of that misplaced confidence. We prioritize our immediate visual logic over the laws of thermodynamics. We assume a cable fits a hole because we want it to, forgetting that physics does not negotiate with our assumptions. As long as builders prioritize their egos over the instruction manual, the tech support morgues will remain full. Because in a battle between a $2,000 precision instrument and a $20 power drill, the always wins.